Welcome to the Fat Emperor podcast. I'm your host, Ivor. We're supported by the Irish Heart Disease Awareness Charity, which advocates a simple CT scan to reveal your CAC score. So, know your score and take action to prevent that premature heart attack. Everything you need to know will be right here.
And then if I understand the kind of the historical background, the healthy physiology, then I may be able to address how it goes wrong. But without having a very good picture of the mentioned two factors, I think it's impossible to get a good understanding of what goes wrong. And then you can come up with crazy things like bombardiering your blood vessels with particles which have been there for millennia, and then suddenly these are harmful.
I agree, and the mechanistic science and the evolutionary science and origins and the healthy state of a body, healthy physiology, what that works like, and all of these things are crucial when you're looking at a new problem to see, what its mechanisms are. But you're right, there's a simplistic view taken that millions of years old, exotic, crucial, say, lipoproteins are now suddenly the main cause, for a problem that only started really in the 19th and 20th century. So there's an absurdity there. We'll come back again. I want to come back to the personal fat threshold, but just because we're on the topic now of cardiovascular disease, and to continue our point, I recently, and based on research, like to look at the primary problematic things to lead to atherosclerosis and the inflammatory issue in your arterial wall. And I try to keep in mind all of the technology and all my research like you do. But there is the number of particles being higher will promote more of the problem. That's the suggestion. And I think that's okay, because if you have a fundamental problem with your system and you pile in more and more lipoprotein particles, it could exacerbate it. I have no real problem with that. So that's one thing. But then I have 5 layers after that, and there's probably 10 big ones, but I've got 5. One is the place of oxidized LDL, right? What place that takes part of. So to what extent the particles oxidized and desialated, I think it's called, in your plasma, trigger the arterial wall inflammation rather than native undamaged. And if oxidized had a big part in this, you would now be looking not at the particles, but what oxidizes them for root cause. Smoking, a million other things. The second then is the glycocalyx, which is the barrier layer on the inside wall of the artery. And there's fantastic science around that it can manage the contact between LDL lipoproteins and the wall. Then you have the endothelial cells, and they can transfer LDL across themselves through an evolutionary design system, to your point, that was all made for the right reasons, we have to trust. And you can leak, to your leaky point. There's evidence for leaking of LDL between the endothelial cells, and that is greatly accelerated by things that insult the endothelial cells and damage the barrier, right? So that science is all there. And the third one is the tendency for the LDL to be trapped in the wall on proteoglycans. And that can be accelerated massively by diabetes and many other causes. And the final one is HDL efflux, that if you do have lipoproteins excessively becoming engaged in the wall, we've got HDL, an absolute miracle working macromolecule that does a million things and stops oxidation, but it also takes out cholesterol as part of its job. And if it is healthy and can keep up, you won't ever get a problematic buildup, one would say. So all of these, and there's many more, I've listed now 5 key things as well as the number of particles. But people don't talk about the 5 crucial mechanistic things and what your health level is in each of those. But the HDL ties us back to the lymph, because something new to me a few months ago was you began to read papers, as we discussed HDL functionality, and you began to connect HDL to the lymphatic system. I always thought of it as coming out with cholesterol from macrophage and simply getting in the circulation and going back to the liver. So maybe talk a little.
If you allow me to step back a little bit.
Yeah.
And you said that you have these 5 or 10 things which you can list, but is there one thing which can explain all the others? Is there a single one which is able to explain all the others? And then I will come back to this HDL stuff very soon, but I have one paper for today in front of me, and it's a list. So everybody will love it because it's just a list of symptoms. So when I ask questions, usually the 2 questions I ask are why. This is one, and the other one is that a normal physiological state which can explain all the observations? And then the problem is eventually the chronic activation of this physiological state, which was intended to be acute, I mean temporary. So if we have a temporary state which can explain all the observations, and the problem is not this temporary state, but that the real problem is that this temporary state is being maintained on and on and on. So medical people call it becomes chronic. Then we face a very different problem, because we have only one problem. So I will tell you, and the paper is called something like Effects of Infection and Inflammation on Lipid and Lipoprotein Metabolism. So what does infection and inflammation do to your lipoprotein metabolism? And then it's a list. Infection and inflammation induce the acute phase response. This is an immune response, mainly described by the so-called innate immune system, and then secondary phases like the liver response and all the other tissues response, and the inflammation builds up. It happens every time you get a virus or bacterial infection or whatever. So what happens with your lipoproteins, with your insulin when this happens? Plasma triglyceride levels increase from increased VLDL secretion as a result of increased adipose tissue lipolysis, increased de novo hepatic, which means liver fatty acid synthesis, so you have DNL increasing in your liver, all the lipid circulation goes up, and then suppression of fatty acid oxidation. With more severe infection, VLDL clearance also decreases, and then secondary to decreased lipoprotein lipase and apolipoprotein E in VLDLs. And then what else happens? You develop insulin resistance and hyperinsulinemia. And also lipoproteins becomes enriched in ceramide, glucosyl ceramide, and sphingomyelin. These are so-called bad lipid things which are connected to inflammation. But why do these go up? Because they need to support your immune system. This is perfectly normal. This is a normal physiologic state when you respond to an infection, for example. And then these lipids are taken up from your lipoproteins, and then these lipoproteins become small and dense, because your immune system empties them because it's needed for quick proliferation, quick dividing of the immune cells, and then the very quick and high level of metabolism of the immune cells. And then all the other stuff, HDL becomes a pro-inflammatory molecule, small and dense and pro-inflammatory molecule. Oh my God, the HDL, the good cholesterol, becomes inflammatory. So these guys just describe what happens in an acute state. But at the end of the abstract, they have a small little comment which is also very insightful. However, if prolonged, these changes in the structure and function of lipoproteins will contribute to atherogenesis. So there you go. You have one single mechanism which basically explains everything you observe. You have insulin resistance and hyperinsulinemia. You have small dense particles of LDL, small dense and inflammatory HDL particles. and everything is basically everything is there, and it's one normal physiological state which is intended to be temporary, acute, and not chronic. But what happens, I believe, what happens is that this state doesn't resolve. So you have this inflammation going on and on and on, and then your system is overwhelmed. And then coming back to the lipoprotein dynamics, LDL and HDL, you have now these higher LDL particle numbers with small dense LDLs, and these are more prone to oxidation because your immune system spits out these reactive oxidant species to get rid of the inflammation, to get rid of the intruders. One of their tools for fighting is releasing the reactive oxygen species. So this state is also associated with higher oxidative stress, which can explain, and of course, then you have the omega-6s, which are more prone to oxidation. All the PUFAs, all the polyunsaturated fatty acids, are more vulnerable. So these are more easily oxidated, and then it exacerbates all the stuff. And coming back to the LDL HDL. So you have these increased LDL flux into the arteries. And then I think actually there is another point which I have to make, is that it's perfectly normal that you have these macrophages, the molecules within your arterial wall, because these are basically everywhere. Some kind of immune cells are everywhere, and the roles of these cells is to take up all the debris again. There is some debris like oxidized LDL, which the liver LDL receptors won't recognize. So if your liver cannot take it up, what takes it up? It's your macrophages in your circulatory system. It's perfectly normal. So when you are healthy, you have some oxidized LDL coming in. This is taken up by macrophages. They become foam cells. They release the cholesterol into the lymphatics, or it is transferred into the ApoA molecule, and then the new HDL is formed, and then all the cholesterol and some other stuff is transferred into this HDL, and then it goes into the lymphatics and goes into your vein under your clavicles, and then it joins the whole blood circulatory system. So this is how it works. But what happens when you have an inflammation? You have an increased influx. So more and more oxidized LDL is coming, which is not taken up by the liver because the receptors don't recognize it. And then you have increased number of macrophages. They try to gobble up all the stuff, and then as usual push it towards the HDL system. Now the problem is that when you have an inflammation, your lymphatics is slowed down, because it's also a route for the immune system, and the immune system needs time to work on the problem. So the lymphatic circulation, the flow of the lymph, slows down, and then your HDL flow slows down together with it. I think it's a simple balance of influx and efflux to the arterial wall. You have an increased influx delivery and a decreased removal. So then it starts building up. And I think it's okay. You can observe it every time you get a virus infection. You are in bed for 4 days, for example, and if you take a sample from a blood vessel, from an artery before and after, you will see these lipid-rich plaques building up in your arteries. And these infections are closely associated. These represent a higher risk of cardiac events, so infarction and these kind of things. After an infection, you are, I don't know, double, triple the chance of developing a myocardial infarction. Why? That's the reason. And the problem is when this kind of inflammatory response becomes unresolved. And it goes on and goes on and overwhelms the system, which has evolved to deal with a certain level of deposition and removal, but not that continuous level of deposition and removal. So that's my current view of it.
I think that's very that's very well summarized, and I resonate to say the least. And that is basically an infectious agent triggering an immune response and associated inflammation, and largely mechanistically can explain all of the aspects of cholesterol lipoprotein involvement with atherosclerosis. And also, you've got the associational data that when you have the infections, yeah, there's huge hazard ratios for events, for instability of plaque. And basically, it kind of explains largely everything with no major discord or conflicting fact. So from my world of root cause, I would say that could be presented to management as a comprehensive and solid root cause presentation, and no one could really call foul with any contradictory fact that would completely, as Karl Popper said, the great Karl Popper, a single negative piece of data against your theory has huge power, much more than 1,000 positive pieces. But for this one, everything lines up. I also have begun quite some time back, and with discussions with you and others, begun to view the circulatory system, the vasculature, as an organ that part of its role is to mop up problematic things in the blood system. And it makes sense when you think about it, because the liver is sent problematic and components to deal with. Fine, the liver is the great clearinghouse. But you've got this enormous surface area of the vasculature that's in contact with the blood, and through evolution would be perfectly placed to carry out functions to stabilize or help with blood. So just take one example there. Like you say, you have oxidized lipoproteins in the blood. The liver does not recognize them so well, and they will become toxic and they are going to cause damage, etc. So the blood vessels have, and the endothelium has a LOX1 receptor. And I've got some great papers on this. And the LOX1, LOX1, is linked to every single mechanistic step of atherosclerosis. But what the LOX1 receptor does in the artery is it takes oxidized LDL, not native, takes oxidized LDL out of the circulation and brings it into the arterial wall, where it goes through the process of being dealt with by macrophage. And if it's acute, this problem, low level, and your HDL is functional because you don't have a major problem, you only have an infection or you only have a problem for a few days, what goes in will be easily taken out and there will be no significant implication. But if you have a chronic problem driving oxidized LDL, and in the laboratory this has been demonstrated that oxidized LDL in the plasma damages endothelial cells and causes a huge amount of destruction. But if you only have a moderate amount, like an evolutionary human, you will never develop the extreme atherosclerosis that leads to events. Your HDL is working, you're not pushing in a huge amount of this, and it won't happen. It's like you say, it's the chronic insult involving the immune system and the damage to lipoproteins. That's the big game. And another point is that it's not just infections, because you've picked a great a case example of an infection that can explain nearly everything in the process. But there's also chronic inflammatory conditions like lupus. There's a hugely increased rate of atherosclerosis. There's also smoking, which causes immune reaction and damages all the lipoproteins. So there's also sugar and sad diets and high carb, bad diets we know cause a storm of damage throughout the body.
We have insulin resistance and hyperinsulinemia, which can also be explained by a chronic inflammatory reaction.
Exactly. So often people say, oh, don't blame the inflammation because that's a natural response. But the point is that the inflammation is a natural response acutely. But if you push it for a sustained period, myriad causes of atherosclerosis that we know about all align with this view of the lipoprotein's involvement. And to come back to what we said at the start, so I would always acknowledge if you have way more lipoproteins to be damaged and to become entrained in this system, this dysfunctional system, by all means, they are part of the process. And if you reduce the number, by all means, if you take the number out artificially, you may mitigate or reduce the rate of the process. And that's all fine. But it doesn't take from the fact that the real root causes, by an engineering standard, are not really the evolutionary molecules. They are everything else we talked about and more. Hey guys, just a quick break to remind you that this podcast is only possible due to funding from the Irish Heart Disease Awareness Charity and its founder, David Bobbitt. David discovered he had massive heart disease in 2012 and could only do so by getting a 5-minute calcification scan and CAC score. It enabled him to take action to stop the disease process and to save his own life. Now he is spending millions to help others do likewise. All we ask is to help get the message out on the power of CAC, watch the Widowmaker movie linked at the end of this podcast, and share it as widely as you can. Thank you, and now we return to the conversation.
That's a crazy idea. I think that generally having more particles shouldn't be a problem, and I think you showed it several times that people with familiar hypercholesterolemia or whatever it's called, they can have much higher levels of circulating LDL particles and LDL cholesterol, but it's not necessarily a death sentence. I mean, if this inflammatory response is not chronically behind, then the system can still deal with that higher number because the balance can be maintained in the arterial wall. And then you can again explain that if you have a functional HDL, a non-inflammatory HDL molecule, and then it is transported into the lymphatics, and the lymphatic flow is normal, then it is just a perfect merry-go-round, and it works. It's not a death sentence at all.
Yeah, and just on HDL functionality, and I often bring this up because it does annoy me somewhat that we see a lot of press about how HDL is not so important and it's not causal and it's only a correlator and lowering it or increasing it doesn't help. But that's because, in fairness, the drugs to increase HDL achieved a paper increase, in the numbers. But of course, they didn't help in any way with this system we're talking about. They didn't improve the functionality. If anything, they might have damaged the functionality as they forced HDL up.
Anyway, it's just a proxy. I mean, what you should, based on this hypothesis, what you should be able to measure is the actual efflux, the loading of the HDL on the other side of the arterial wall into the lymphatics. And the normal function of HDL going and returning to the blood circulation through the lymphatics. And everybody is measuring it in the blood. This is the first problem. When by the time it reaches the blood, a lot of things happen to this HDL molecule. So it's not, I mean, it's not just counting. The function is not only by counting them, but we have this many, and then we know how they function. That's not how it works.
Yeah, and the way I would look at it from the data and the published science, if the HDL number that you say is higher, it correlates with better outcomes. And this has been known for many decades. And if the HDL is higher, generally the LDL being high doesn't seem to matter. But all of this would make sense, not because HDL is causal through its number, but because a higher HDL generally correlates with a more functional HDL and better efflux. That's all.
With lower inflammation.
Yes, and with lower inflammation, because a higher HDL correlates with lower insulin resistance, lower hyperinsulinemia, and it also correlates with many other good things like exercise. It goes up. The one exception is excessive alcohol can make it go up in a dysfunctional way. But there's always going to be exceptions. But the key thing is that the higher HDL tends to correlate with better HDL efflux and functionality. And that's why the higher simple number can tend to look like a good thing. But that study we talked about a couple of months ago, we'll have to mention, and I'll put it in the video and attach it, of course, where they actually measured in the laboratory exactly what you said, the HDL lipoprotein efflux capability and capacity for individuals, and gave that a number. Now that's science, and it's the only example I've seen. And what they saw in a large cohort of people where they had them tracked over 8 or 9 years, and they had the data on who had events and who hadn't. They got their blood, and for every person in a petri dish or in a test tube, they actually found out how good the HDL was at effluxing cholesterol from macrophage. And they functionality, and they gave a number for the HDL efflux capacity for every person. And guess what? The HDL efflux capacity for a person indicated a 70% lower chance of a future heart event and a 90% lower chance of a future stroke. So if you measured the HDL for these people, and they did, it showed the usual high HDL reading in the blood, 30% lower future chance. But the efflux capacity properly measured showed 70 and even up to 90% lower stroke rates. So the power of measuring the right thing. So when anyone hears on the radio or on the television people questioning HDL's importance, keep that in mind, that they're all talking around completely irrelevant points, and they're not talking about the actual science at all.
Understanding healthy physiology is absolutely mandatory to be able to come up with a viable hypothesis. That's the basis. And yeah, I'm now there with regard to the immune system, because I graduated mid 90s, and what you studied during the 90s was basically you have this immunity, mainly adaptive immunity. You have these T cells, B cells, and they remember all the patterns coming from the infectious agents and how they react the next time. And then the innate immune system, which is the first level of defense, and which is the first level of the first surveillance system in the body, was in its infancy. So basically, we knew about we have these macrophages, and they can gobble up things, and that was almost it. And the big revolution of the innate immune system started exactly in the mid 90s. So I think it's still not fully implemented in biological education. So, for example, if you are at a medical school right now, I'm not sure you get the level of knowledge what we already have in the scientific journals. And then it needs to, I think usually it takes 20, 30 years to get through the system, so that it gets mainstream knowledge, and that becomes mainstream knowledge, and from that it will make it into textbooks, and then people will better understand how the system works. So I'm actually I've been back to the drawing table for a couple of months now. I've been studying innate immunity and immunometabolism. This is a crucial thing, and this enables you to understand basically hyperinsulinemia and insulin resistance, how it develops. I mean, there is a normal physiological state again, where your immune system initiates hyperinsulinemia and insulin resistance, so that they can get the stuff which hyperinsulinemia and insulin resistance results in. All the excess nutrients, all the extra lipids, what the immune system needs for activation. So this is a perfectly normal state again. Becoming insulin resistant, and even often hyperglycemic, developing high blood glucose during an infection. It's normal. So what is diabetes then?
Yeah, and that's exactly it. And I often say myself that hyperinsulinemia, insulin resistance, has a huge part in the causal pathways, but also all of the bad things that cause issues, overwhelmingly, most of them cause hyperinsulinemia and insulin resistance to occur as a reaction. So then those measures act as a gauge. So if you can have very low insulin and very high insulin sensitivity or low insulin resistance, you may still have some issue going on, and you might find it with some other blood markers, but you know you're way ahead of all the people around you in the modern world just by having low insulin and great insulin sensitivity. It's one of the biggest metrics you can target. Whatever way you do it, you might have to give up certain foods that are causing an inflammatory response. You'd have to give up smoking, right? You'd have to eat a healthy, nutrient dense diet. You may have to get sun exposure, a reasonable amount. There are many things you'll have to do to become very healthy and get longevity. But the insulin resistance hyperinsulin gauge will give you a pretty good indication that what you're doing is likely to be pretty good and bode well for the future. I think of it as if you have an airplane and you're flying a high-tech airplane, you'll have many gauges. There are many blood tests, but you don't depend on one. Like the particle number is one gauge that you need to watch, but there have been countless crashes where pilots have fixated on one gauge that's worrying them, and they've lost their spatial reasoning and they've lost the big picture. And in that aircraft analogy, I would also add that the insulin gauge is one of the most important gauges. Again, you don't just stare at it and ignore everything, but it is a really important one. It's probably like the attitude indicator in the middle of the panel. So a bit off there on analogies, but I agree totally. Now, I know you and me both have hard stops coming up, but I really would like to come back and talk again on some of these topics because they're so rich. So we're certainly going to do that. But if we could finish perhaps and wrap up with, if a person has a very significant issue, likely autoimmune components, because that's very common, or obesity, diabetes, all of the modern chronic diseases, what would be the first steps in your diet and lifestyle in sequence that you would take to start dealing with a very significant issue, right? So 1, 2, 3, 4 kind of thing.
It comes back to my kind of unifying theory of every maladies of disease of civilization, and I tend to believe that the differences we see between people. I mean, if there is only one mechanism underlying, or a bunch of very similar mechanisms underlying all these modern diseases, then how comes that we see so different manifestations of this? So some people develop diabetes, some people develop obesity without diabetes, other people develop autoimmune diseases or allergies, or whatever. And if we come back to the immune system and chronic immune activation, then and we do know that it's mostly not genetic. So there is a genetic component, there is an epigenetic component, there is a prenatal conditioning, intrauterine, so within the womb, and early infancy conditioning. So there is some predisposition, of course. But this booming of all these metabolic diseases, and we can mention also cancer because it's linked to an impaired immune system, is extremely close. Then you start thinking about what are the disrupting, what are the environmental disrupting factors, if it's not genetic. And then there is an old study, not that old, a couple of years old, when I saw that there is this single cell organism called the baker's yeast, or brewer's yeast, whatever you like it to call. So the yeast is a single cell organism, and the biggest stressor on a yeast is, guess what? Feeding. So whenever it starts feeding, all the stress molecules within the single cell goes up, go up. All the stress factors go up, and it stops feeding, stress decreases. And there are, of course, other factors similarly converging upon the same pathways. And this is chronic stress, circadian disruption, so lack of sleep, poor quality sleep, wrong timing of sleeping, and these kind of things. But this is chronic stress basically, because it activates the stress response. And then you have the smoking. We discussed smoking, and there are some others, like some people are really focused on getting blue light in the evening, and they believe that it's the start of all problems, and then these are all contributors. And then these environmental chemicals, the exposure to air pollution, to phthalates, BPA, whatever. There are thousands of these, and these add up. But the single biggest one, I still believe, what you can easily manage is feeding. And feeding is what you eat, when you eat, uh, your food order, when you don't eat. I mean, some intermittent or even maintained fasting. So this with these you can eliminate a huge chunk of stress from your body. Just adding the nutrients, the foods, what you really need, and causing the least possible amount of stress with feeding. It always causes stress. Don't forget that whenever you feed your all the interleukin 1 beta, and these go up, so it can easily be measured. And then there are some smart tricks, and I learned from you this Pareto principle, that doing 20-25% or making 20-25% of the effort, you can get to 75-80% of the results. So if you are smart, you implement only what's really important. Leave out a few foodstuffs which are really inflammatory, endocrine or immune disrupting, like modern grains, most common grains, which result, you remember my talk, in imbalanced stimulation of the gut, and don't eat very frequently. Forget about even the word of snacking. Snacking is a modern word. Our ancestors had no clue about what snacking was, and when you eat different kind of foods, you can include carbs, even some quick carbs, maybe depending on your current metabolic health. But then eat your salad first, proteins and fats second, and only quick absorbing carbs last. Never eat something which is quick absorbing, consists of quick absorbing carbs and added fats without any structure and proteins. So this is dangerous. And
Yeah.
guess what? These items are mainly so-called ultra-processed industrial foods. Most of the foods our ancestors recognized as food are okay still.
Yeah.
Not surprising.
It is not surprising in the end, but like we said earlier, it's very confusing if you're looking at an exploded jigsaw. But it's not that surprising when it's put together, and it almost becomes obvious, if you will. So a real foods diet, depending on your insulin sensitivity or your level of tolerance, simple carbs, be very careful with. You eat nutrient dense fats and proteins, and ideally put the carbohydrate, especially if easily digested, towards the end of the meal. And that's actually quite interesting trick. Some people prefer to remove the quickly digested, but you can keep it at the end of the meal to help with metabolism and get all your nutrients. It's a whole foods, lower carb, certainly low, high glycemic carb kind of diet, and eat maybe twice a day and occasionally once a day is one of the ways I view this.
Yeah, absolutely. And uh, coming back to the gut stimulation, which is one of my favorite topics, um, I dealt in great detail before with the imbalanced hormonal stimulation these ultra processed foods can cause, and just when preparing for my talk last May, I recognize, but of course there was not enough time to include this one, that this imbalanced stimulation is also one of the main reasons for seeing the impaired intestinal barrier function. So when you have lower upper intestinal stimulation and higher lower intestinal stimulation, actually what you see that these lower intestinal hormones, together with the surrounding immune cells, create a very strong intestinal barrier function. So you don't have this leaky gut. This is exactly the same pathways, just different hormones. I mean, then I focused on insulin-releasing hormones, upper intestinal and lower intestinal, but the same L, so-called L cells, releasing GLP-1, release GLP-2, which is kind of the guardian of the intestinal barrier function. And guess what? If it's stimulated by the same mechanism, by the same foods. So it's released when the cell is stimulated. But if the cell is not stimulated because you absorb everything in your upper small intestines because you eat donuts, and don't be surprised that you develop a leaky gut.
Yeah.
And then we can also come back to the I mentioned the fat absorption, that long chain fatty acids are not absorbed to the portal circulation, so they don't go directly to your liver, but instead they are taken up by the lymphatics in so-called kilomicrons. These are lipoprotein molecules, the largest of all, because they are loaded with triglycerides, the fat that you absorbed. And why? I mean, again, a question comes: why are these not absorbed to the portal circulation and go directly to the liver?
Yeah. Well, you know, there's an excellent few topics, and we did go through GIP, GLP-1, GLP, not GLP-2 in Budapest last year.
That's a new addition.
Excellent. And I've seen it. I've been very busy, but I've seen it on Lower Insulin Facebook group, which you run. I've seen the papers coming and I've made a note. I'm going after you for those. So next time we meet, we'll go through the whole intestinal hormonal balance, how the food's affected, and all of this new science, which explains and unifies not just the disruption of your intestinal hormones that in one pathway lead to obesity and chronic disease, but now unifying that with the other basically the other immune type pathways, GLP-2, and tie it all together for people. So no processed food, no refined carbs and sugars, no vegetable oils. And we might also next time talk a little bit around the plant world foods that may be a big problem for some people, while not for others. Excellent. So hey, thanks a lot, Gabor, and always a pleasure. There's no question about that.
Thanks for inviting again.
No problem. We'll catch up next week as well. Have a great day.
Yeah, have a nice day. Bye-bye.
Thanks for tuning in, guys. If you're watching on YouTube, you can see my subscribe button in the middle of the screen, a free viewing of the Widowmaker movie on the far right, and myself and Dr. Gerber's book, Eat Rich, Live Long, on the left. Otherwise, please do subscribe to the audio podcast. Thanks.